Good evening, everyone.
Good evening, ma'am.
So we'll wait for a few minutes. I think we'll start the session at about 6:10. Is that fine? Because I'm hoping some other students will also join this session. Okay, so is the screen visible? Anyone please confirm that is the screen visible to you all? Hello? Hello? Okay, thank you. Someone has confirmed that the screen is visible. So I think we'll wait for 2-3 minutes more, then we'll start the session.
Ma'am,
Yes,
there's a small doubt that I had, ma'am. This
sure.
assignment in week 3.
Yes, okay.
In week 3 assignment, there was a question in the uh, uh, assignment which they had asked to compute the air quality index.
Okay,
So in that, no, ma'am, it was asked PM10, the concentration is 90, and another CP value is given.
okay.
So in that case, when you do air quality index, which value for concentration will you take?
See, I think I've not gone through your assignment third. Today we'll be discussing your assignment for week 2 only.
Okay.
So, can you please send the question to me in the chat or somewhere else?
Yes, ma'am. Yes, ma'am. I'll just send.
Okay, okay.
Thank you so
I'll
much.
take your doubt. Just wait for a
Yes,
few minutes because
no
I need
problem.
to
No
start
problem.
the section.
Take it. Thank you.
Okay, okay.
That was a
Okay, so I think we should start the session now because it's already 6:10. Okay. So still some students are waiting. Okay, so is the screen visible to you guys?
yes, ma'am. Yes.
Okay. So, good evening, everyone. Today we are going to have our weekly tutorial session 2. In this tutorial session, we'll be discussing the assignment, the previous year's assignment that was given to you guys for the week 2 lectures. I'm hoping you must be having your week 3 assignment for the current year questions as well. So in this session, we'll be discussing the questions that were given in the past year assignment. So let us begin the session for now. Okay. So for the first question, air pollutants which forms the haze impacts visibility of light impacts visibility by dash of light in the atmosphere. So we all know about some of the phenomena such as scattering, absorption, adsorption. So for this, we have first option as scattering and absorption. Second one is only scattering. Third is only adsorption, and fourth one is none of the above. So any idea about this? A. Okay. What about the others? Anyone else? Okay. So let me tell you the answer. The answer is A, scattering and absorption. So how it is done? Let me tell you. Basically, haze. What is haze? Haze is caused when the sunlight encounters tiny particles in the air. What do we mean by encounter here? Basically, a sunlight when it's traveling. Participants are still coming and it's creating a lot of disturbance in the class. Okay, leave it. Okay, so what happens here is when sunlight travels in the air, so the tiny particles of dust they try to come in between the path. So due to this, some of the light it gets absorbed by those particles, and some of the light it scatters into the atmosphere because of this hindrance. So basically, the more the number of the particles in the air, and the more the scattering and the absorption of the light, due to to reduce the clarity and colors of what you see. So haze is basically what it is. Basically, the reduction in the clarity of the colors or visibility. Basically, the hindrance in visibility. That is what haze is. So the answer will be scattering and absorption. I think it's clear to everyone now. So let us move towards the question number two. Which of the following material is more resistant to acid rain? Um, is there anyone who knows the answer? Which of the following material is more resistant to acid rain? Among the given materials, first one is quartzite, granite, gneiss, limestone. Which one is more resistant to acid rain? Yes, D, limestone. Okay, Anshu. Anshu has answered it as limestone. Okay, Anshu, your answer is correct. It will be limestone only. So, in the given picture, you can see that these holes that have been formed in the material, it is due to the degradation of the material. What it does is basically when the acid rain occurs now, both marble and limestone these are made up of these contain calcium carbonate. So we all know that calcium carbonate is a base, and uh, bases are able to neutralize the acids. So due to this process, when acid rain occurs, these tend to react with those acids and neutralize them. So that is why they are more resistant towards the acid rain. So the answer will be limestone. And this degradation of material, this occurs due to that reaction which occurs between the base present in these materials and the acid present in that acid rain. Clear? Okay, so one thing I would like to tell you all that I want this session to be a bit more interactive. So, and every time I ask any question or want to know something from you guys, I'm hoping that you guys are also listening to that and be responsive towards that. Please feel free to turn on your mics and ask any doubt or any question or anything that you want to share with us, because this is just a session discussion session between the tutor and the students. So I want this session to be as interactive as it can be. So okay, moving towards the third question. Identify the criteria pollutant from the following options. First one is carbon dioxide, second is dioxin, third is carbon monoxide, and fourth is asbestos. So, okay, answers, anyone? Okay, so anyone has the idea about what are the criteria air pollutants? C. Carbon monoxide. Okay. Okay. So moving towards the next slide. Basically, uh, the options given here are these are the criteria air pollutants. These six pollutants which are ground level ozone O3, particulate matter, carbon monoxide, lead, sulfur dioxide, and nitrogen dioxide. These all are the criteria air pollutants. So basically, the Clean Air Act requires EPA to set national ambient air quality standards for specific pollutants to safeguard human health and the environment. Excuse me. So, in this act, some standards have been set for some specific pollutants. For example, what are the permissible limits for these pollutants? These six pollutants: ground level ozone, particulate matter, carbon monoxide, lead, sulfur dioxide, and nitrogen dioxide. So basically, these standards define the level of air quality that EPA determines that are necessary to protect against the adverse impacts of air pollution. And these common air pollutants, these six air pollutants, these are referred to as criteria pollutants, for which the standards have been set by the EPA. And in India, basically the India has revised the national ambient air quality standards and notified 12 parameters, which were earlier these parameters were six, which were described by EPA. Now it has been converted to 12 pollutants that have been revised by India. And these parameters include PM10, PM2.5, NO2, SO2, CO, O3, NH3, lead, nickel, arsenic, benzoapyrene, and benzene. These are the 12 parameters which are being included in India's revised National Ambient Air Quality Standards. Although AQI is usually based on the criteria pollutants that are PM10, 2.5, sulfur dioxide, nitrogen dioxide, carbon monoxide, and ozone. But the above pollutants are also harmful, and these needed to be the standards are needed to be set for these pollutants as well. So for the above question, I guess the answer will be carbon monoxide. Coming towards the next question. Okay. The ozone layer, which protects the earth from harmful UV rays, is located in the previous class, we have discussed about the various layers of the atmosphere. So, from all those layers, which layer contains the ozone? Troposphere, stratosphere, mesosphere, and exosphere. The troposphere. Anyone else? Okay, troposphere. Most of the students are answering it as a troposphere. Anyone else who's answering a different one? Okay, so before giving the answer, let me share something with you. As discussed in the previous class, the ozone layer extends from 0 to 10 kilometers above the surface of the earth. And sorry, not the ozone layer. The troposphere extends from 0 to 10 kilometer, and the stratosphere extends from 10 to 50 kilometers. So this ozone layer that is present above the troposphere, so it will be stratosphere only. The ozone layer is present in the stratosphere because all this is stratosphere. It extends from 10 to 50 kilometers. And what ozone layer does is it is a ring of protective gases around the earth, and it absorbs the harmful UV rays that come from the sun. To it basically it resists these harmful UV rays to come to the surface of the earth, and it is located approximately 10 kilometer above the earth's surface. So ultimately it gets above the troposphere. So it will be present in the stratosphere only. So the answer will be B, stratosphere. Clear? Okay. So next question is, formation of ozone is an example of phase transformation from option A, liquid to gas, B, solid to gas, C is gas to gas, and D is liquid to liquid. C, gas to gas. Anshu. Okay. Anyone else? Anson was also answered as C. Okay. Okay, so basically before answering this question, we'll discuss the formation of ozone. Formation of and the destruction of ozone is a natural cycle. So it is formed due to a single recombination reaction between in an atomic oxygen. This is also termed as nascent oxygen. So the reaction occurs between this nascent oxygen and a molecular oxygen and the presence of a third body M. What is this M? This is a gas that is required to carry away the energy released in the reaction, and it is usually oxygen or nitrogen. So if this will be oxygen, this can be oxygen or nitrogen, and this gas is released after the reaction. So this process is the formation of ozone. So all these are present in the gaseous form, and these are also in gaseous form. So the react answer will be formation of ozone is an example of phase transformation from gas to gas. Okay, so coming towards the next question. The dash is the major chemical scavenger in the troposphere, and it controls the atmospheric lifetime of most gases in the troposphere. Option A, ozone, B, hydroxyl radical, C is photochemical smog, and D is volatile organic compounds. Okay, I think some students have answered this. B, Anshu has answered as B, hydroxyl radical. Okay, so this is the correct answer. Basically, the hydroxyl radical is the major chemical scavenger in the troposphere, and it controls the atmospheric lifetime of most gases in the troposphere. Okay, so what is a scavenger? What is this term? What does this term means? Any idea? What is this scavenger? Basically, scavenger is something that feeds on decaying matter. So hydroxy radical is a very reactive radical, and it is responsible for the reaction between most of the gases for the basic what how do we say for the phase transformation of different gases. The main radical that is responsible, that is hydroxyl radical, and in the troposphere it is the primary oxidant of both natural and anthropogenic hydrocarbons, and it also leads to the production of pollutant ozone. Now for the next question, the earth rotates on its axis. Circulating air is deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. This deflection is called, first one is circulation, B is Coriolis effect, C is convection, D is none of the above. Okay, Anshu has again answered B, Coriolis effect. Okay, okay. So this answer is correct. It will be Coriolis effect. And this effect is responsible for many large-scale weather patterns on the Earth. This leads to the wind movement in the atmosphere, and also it is responsible for the weather patterns and the change of temperature or change of pressure. This effect is responsible for that as well. So for the next question, the process of conversion of a liquid chemical into a vapor which then escapes into the atmosphere is called as A. Volatilization, B. Adsorption, C. Absorption, D is ionization. Any answers? A. Volatilization. Okay, the answer will be A. So, volatilization is a conversion of a liquid chemical into the vapor, and this vapor then escapes into the atmosphere. This mechanism is a physical process. For example, this process can be seen in fertilizers. When a fertilizer is applied on the fields, it is in liquid form. But after that, after some time, what happens that is this liquid then converts into gas. Which gas is released from the fertilizers? This ammonia gas. And this whole process of release of this gas from this liquid phase is termed as volatilization, and this mechanism is a physical change. Now for the next question, consider the following figure and select the correct option. In the last class I have discussed very well about the like rising and sinking of the air parcels. So here the temperature of parcel is 15 degrees centigrade, this 15 degrees centigrade, and the temperature of air is 10 degrees centigrade. So ultimately the temperature of parcel is more than the temperature of air. So what will happen here? If the temperature of a parcel is more than the temperature of air, the air parcel will ultimately rise, sink, or there will be no change. What will be the answer? Okay, so Anshu is saying B, sink, and someone A B is saying rise. Okay, so I'm getting mixed responses. Okay, let's wait for some time, and I need some more responses because I have discussed this concept in a very much detail in the last class. So let's wait for some time and see what others responding. Okay, if anyone who was present in the last class is still present in today's class, I want someone to recall this concept of rising or sinking of air parcel. Is there anyone who can share this concept with us all? Anyone? Is there any problem with your mics? Because can see no one is unmuting themselves or sharing any answers. Okay, since Anshu is answering most of the questions, so I would like to ask you to turn on your mic and try to explain how will this
I think
happen.
no, I think my answer is wrong. I think it'll rise
It will rise.
because
Okay.
I don't because I always get confused with the concept because it is warm air and it's a tendency to rise.
Okay.
Like for example, if the parcel is like some pollutant, it's coming
Yes.
out from a stack, and if the pollutant's temperature is higher than the surrounding ambient air, then it has a tendency to rise. Now,
Correct. Correct,
if
Anshu.
if
This
the
your answer is correct.
now if the temperature is less or something like inversion or something like that happens, sandwich is formed, so it'll I do something like that.
Yes. Yes. Correct. Correct, Anshu. Your answer is correct.
So that's the
Good job. So okay. I'll explain this. So basically, what happens is, for example, let us consider we have an air parcel, and for example, its temperature is Tp, and the temperature of ambient air is Ta. So this is a very general concept that unless and until the temperature of this air parcel is more than the temperature of the ambient air, Tp is more than Ta, it will always rise and expand. And when the condition is such that this temperature of parcel is less than the temperature of so I hope this is edible to everyone, audible to everyone.
Yes, ma'am.
Okay. So what happens here is when the temperature of the parcel is more than the temperature of the ambient air, it will ultimately rise and expand. And when such condition arrives, when the temperature of the air parcel or the pollutant that is being emitted is less than the temperature of the ambient air, this can be seen observed in winters, or in situations where we have lower temperatures. So the air parcel will ultimately sink and it will contract. And when the temperature of the air parcel is equals to the temperature of the ambient air, then there will be no change in this situation. The air parcel will remain as it is in the atmosphere where it has been released. So for the next question, and this is the last question for the session, because every assignment has 10 questions, 10 objective questions. So this is the last objective question. So consider the following figure and select the correct option. Here, what we have is, this is ELR. What is ELR here is? ELR is environmental lapse rate. DALR is dry adiabatic lapse rate, and SALR is saturated adiabatic lapse rate. So in this condition, what is the situation of the atmospheric stability? Is it absolutely unstable? Is it absolutely stable? It is conditionally stable, or is it neutral? I hope you all must have understood the concept of stability by now. Anyone? Okay, so I think in the last class also some of the students wanted to know about this concept of stability. So I thought, why now we take your lectures, the presentation that were discussed in your lecture, and okay, so I'll try to explain this concept of stability to you guys. So atmospheric stability, basically what is this? The air movement in the atmosphere is strongly influenced by the atmospheric stability. What it does is, when the atmosphere is when the atmosphere is stable, what happens is, when the atmosphere is stable, the pollutant tends to like sink, or what happens is the pollution increases, and the concentration of pollutant that is there in the atmosphere, it eventually increases because of this stability of the atmosphere. And when the atmosphere is unstable, what happens when the pollutant is emitted? It gradually moves upwards, and eventually the level of pollution decreases. And when the atmosphere is neutral, then the parcel is the at the same temperature as the surrounding, so there will be no change. So basically, what kind of temperature is what kind of stability condition is best for us? That is unstable, when the atmosphere is unstable, because here there will be minimum pollution load, and here the maximum pollution will be there, because all the pollution will tend to come towards the ground. So as discussed in the previous section, what is stable atmosphere? When the temperature of the parcel is less than the temperature of the air, the parcel is basically cooler than its surroundings, so it sinks and compresses. And what is unstable environment? When the temperature of the parcel is more than the temperature of the air, so the parcel is warmer, and it will tend to rise and expand. So this concept of stability can also be explained in, like for example,
If you see this ball, so this is a cliff, for example, and if we just disturb this ball now, it will suddenly come downwards. Basically, it will change its position. And here, if for example this blue ball, if we try to push this, it will come upward for some distance, for example for this. But ultimately what will happen now, it will come back to its original position. So this is stable. And then what is neutral? Neutral is something when, like, if you push this ball now, it will just change its position. It won't come back to its position, or it no, neither it will go too far from its position. It just depend on the pressure that you're giving to it now. It will displace by that distance only. So this is the concept of stability. Now for the atmosphere, the rising is unstable condition. When the air parcel is rising, this is unstable. When the air parcel is tend to be sinking, it will be stable atmosphere. And when it will be staying in its own position where it has been emitted, it will be neutral atmosphere. So the atmospheric stability depends on the variation of the temperature with the height or the altitude. In general, stability refers to the tendency of air to rise or to resist the vertical motion. So it will determine the atmospheric status in terms of whether or not the air parcel will rise, sink, or be neutral, as explained in the previous section. As the air parcel rises, it will expand and cool adiabatically to its dew point at which the clouds are formed. Basically, this air parcel, as it rises, it expands and it also cools down. So they will after some point, what will happen is the temperature of this parcel will be the same as the temperature of the air, and it will stay there. This is the process of the cloud formation. Okay, so I think I have explained these three type of stability conditions: stable, unstable, and neutral. What is unstable atmosphere? Basically, when the air parcel is warmer than its surrounding environment, then it will be less dense than its surrounding, and it will rise like a hot air balloon. For the stable atmosphere, if the air parcel is cooler than its surrounding environment, then it will be denser than its environment, and it will tend to sink. And for the neutral environment, the air parcel has the same temperature as its surrounding environment, and the parcel will not move, and it will remain in suspension in the atmosphere. Basically, no change in the position of the air parcel will happen. So how will you determine the atmospheric stability? How will you determine what kind of atmosphere is there? So it depends upon the environmental lapse rate, ELR, environmental lapse rate, the dry adiabatic lapse rates, DALR, and the saturated adiabatic lapse rate. So the measured environmental lapse rate. What is environmental lapse rate? I'll be discussing in the coming section. The measured ELR can be compared with both the dry and the saturated adiabatic lapse rates to determine the atmospheric stability conditions. So what is environmental lapse rate? Basically, in the troposphere, the temperature of the ambient air normally decreases with an increase in the altitude. As we increase the height, the temperature tends to decrease. So this change of the rate of change of the temperature with the increase in the height is called the lapse rate. This is minus delta T by delta Z. Basically, this minus sign represents that decrease in the temperature. This is lapse rate is equals to T2 minus T1. T2 is the temperature at height Z2. This height at Z2 the temperature is T2. For example, in this case the height Z2 is 1 kilometers. So this height Z2, at this point the temperature is T2, and the height Z1, basically at the ground level the temperature is T1. At Z1 the temperature is T1. So the lapse rate will be T2 minus T1 divided by Z2 minus Z1. Basically change in temperature per change in altitude. So there is a device that is used to measure the environmental lapse rate. It is known as radiosonde. A radiosonde is a battery-powered telemetry instrument carried into the atmosphere, usually by
Excuse me,
a
ma'am.
weather balloon. Yeah, sure.
Can you increase the shown presentation? Actually, it is showing very small.
Okay.
Can you?
I think this one is fine.
Yes, yes. Thank you.
Okay, okay. You must have told me earlier. No issues. Okay. Is this fine with everyone?
It is fine for me, ma'am.
Okay. So basically, what is radio sound? It is a battery-powered telemetry instrument that is carried into the atmosphere, usually by a weather balloon that measures various atmospheric parameters. So this is the weather balloon. This is your weather balloon, and it rises through the atmosphere and measures temperature and other properties on the way. It tends to rise, and it also there's a payload that is tied to its end, and it is a basically this balloon has helium gas filled in it so that it can rise. So on the route, when it tends to rise in the atmosphere, it measures the temperature and the other parameters, and the rate of this rise of this balloon it will differ from place to place, and from time to time, even at the same place, because the density of the air or the velocity of the air will be different in different situations. So this method is used to find the environmental lapse rate. This device is used for that. Okay, so adiabatic lapse rate. What is adiabatic lapse rate? Well, basically, before getting into the adiabatic lapse rate, I would like to explain to you what is a adiabatic process. So, adiabatic process is something where no heat exchange occurs between the given sample and its surrounding. For example, if we consider a parcel of air, so as this process in the process where the parcel of air is rising or sinking, this whole process is assumed as adiabatic process. Basically, it is assumed that there will be no heat exchange between the parcel and its surrounding. And so adiabatic lapse rate is the rate at which the temperature of an air parcel changes adiabatically in response to the compression or expansion. When the compression will happen, it will happen when the air parcel will sink, and expansion it will happen when the air parcel will rise. So accordingly the temperature of due to the temperature of air, the difference in the temperature of the air parcel and its surrounding, this compression or expansion will happen, and the rate at which the temperature changes is termed as the adiabatic lapse rate. So it is of two types, dry adiabatic lapse rate and wet adiabatic lapse rate. So what is dry adiabatic lapse rate? Basically, when the atmosphere is dry, which this atmosphere may contain the water vapor, but the air parcel is unsaturated in this condition. The relative humidity is less than 100%, so the air parcel will cool at the dry adiabatic lapse rate, and the value of the dry adiabatic lapse rate is 9.8 degrees centigrade per kilometers. DALR is equals to 9.8 degrees centigrade per kilometer. And wet adiabatic lapse rate, basically the rate at which the atmosphere is saturated, and the rate of change of temperature when the atmosphere is saturated. The humidity is 100%. Here the humidity is less than 100%. So this lapse rate is called as wet adiabatic lapse rate, and here it is also termed as moist adiabatic lapse rate or the saturated adiabatic lapse rate. Wet adiabatic lapse rate is also termed as saturated. SALR is also known as SALR, and its value is 6 degrees centigrades per kilometer. So the heat released by the condensation mitigates the adiabatic cooling effect, resulting in the parcel of an air being warmer than it would be based on the dry adiabatic cooling. So this the value is basically lesser as compared to the dry adiabatic lapse rate. Its value is 6 degrees centigrade per 10 kilometers. Now, okay, so coming towards the specific stability conditions. In first case, what is absolute stability? Excuse. Okay, so what is absolute stability? It will happen when the dry adiabatic lapse rate is more than the saturated adiabatic lapse rate, which is more than the environmental lapse rate. See, this is understood that DALR will be more than SALR in any case. So when these two are more than the ELR, then the condition of stability will be absolutely stable. The environment will be absolutely stable. In this case, both the plots are on the left or cool side of the LR, that is, both are on the stable side, and this is termed as the absolute stability. So in this condition, in this atmospheric condition, air pollution of air parcel of any relative humidity that will cool faster than the surrounding environment and will not rise. It will tend to sink and create the clear skies.
Excuse me, ma'am.
Yes.
Can you please explain again the DALR, dry
Okay.
adiabatic lapse rate,
Yes.
is greater than SALR?
Yes.
It means the temperature of DALR is greater than the temperature at SALR.
No, it's
Environment,
not like the
environment.
temperature at a DALR. Basically, the rate of decrease, the rate of change of temperature with the height, that is more than more in a DALR. From this graph, as you see now, the slope of this line, it is more than this, na? Basically, here what we are saying now, what this DLR, dry adiabatic lapse rate, the rate of change of temperature with respect to height in dry conditions, that is more than SALR, and these two are more than the ALR. So ultimately what will happen ना कि अगर आप for example you assume ना कि इसमें क्या होगा ना कि जो हमारा पार्सल जो है वो कंपैरेटिवली जल्दी कूल डाउन होगा देन द सराउंडिंग एनवायरनमेंट, बिकॉज जो ये लैप्स रेट की वैल्यूज है, दिस चेंज इन टेम्परेचर ना, दिस इज मोर विद रिस्पेक्ट टू हाइट. फॉर एग्जांपल अगर हम एक किलोमीटर का रेंज लेते हैं, दिस 1 किलोमीटर डिस्टेंस, तो हमारे पास एक एयर पार्सल है जो कि अभी फॉर एग्जांपल अगर अभी 10 डिग्री सेंटीग्रेड पर है, या नॉट विल बी 10 फॉर एग्जांपल 100 डिग्री सेंटीग्रेड पर है, और हमारा एटमॉस्फेयर अभी 40 या 50 डिग्री सेंटीग्रेड पर है. तो अभी यहाँ पर अगर ये 10 और 50 था, तो 100 और 50 है. तो एज वी मूव अपवर्ड्स ना, ये कंपैरेटिवली जल्दी कूल डाउन होगा with the change in height as compared to the atmosphere. हो सकता है after 1 kilometer it is like 40 or 30, and it will still be like 30 or 10. So here what will happen is ना कि जब भी एयर पार्सल जो होगा वो हमारे सराउंडिंग एनवायरनमेंट से जल्दी कूल डाउन हो रहा है, तो आफ्टर अ सर्टेन पॉइंट इट विल नॉट राइज, it will tend to sink and create the clear skies. What clear skies means, the all the air pollutants it will sink down to the surface. सरफेस पे पॉल्यूशन ज्यादा हो जाएगा, और हमारे जो स्काई होंगे वो सारे क्लियर हो जाएंगे, बिकॉज जो भी पॉल्यूशन है वो हमारा सिंक कर रहा है, सरफेस पर आ रहा है. So this condition is known as the absolute stability condition.
That is fine.
Okay. So what is absolute instability? Here what will happen is na, ELR is more than DALR, which is more than SALR. So in this case, what will happen is the environment will tend to cool down at a faster rate as compared to the air parcel. So in any condition, अगर environment हमारे एयर पार्सल के कंपैरिजन में जो भी हम एम्बिएंट एनवायरनमेंट है वो जल्दी कूल डाउन हो रहा है, तो हर सिचुएशन में क्या होगा, जो भी हमारे एयर पार्सल है उसका टेम्परेचर ज्यादा रहेगा एम्बिएंट एनवायरनमेंट से, तो उसकी वजह से क्या होगा, वो राइज करेगा, और वो राइज करते ही जाएगा, बिकॉज द पार्सल इज कूलिंग मोर स्लोली देन द एनवायरनमेंट. तो हमेशा वार्मर रहेगा सराउंडिंग एनवायरनमेंट से, तो वो हॉट एयर बलून्स की तरह ऊपर की तरफ राइज करता रहेगा, एंड दिस कंडीशन इज कॉल्ड एब्सोल्यूट इंस्टेबिलिटी. Is this clear?
Yes, ma'am.
Okay. So in the next case, this is conditional stability. Here what happens is the ELR, this is between these two values, the dry adiabatic lapse rate and the saturated adiabatic lapse rate. So what will happen is, so हम इस केस को ना सेपरेट करके कंसिडर करते हैं. First this two and second this two. So for the dry parcel, for the dry parcel, the DALR is more than ELR. So what will happen is the dry parcel will be stable, because जो हमारा air parcel है, for example, what is dry parcel? Basically, its humidity is less than 100%. So अगर हमारा जो भी air parcel है वो dry है और उसका जो lapse rate है that is more than the environmental lapse rate, तो ये जल्दी cool down होगा as compared to the environment. So in this condition, what will happen is it will be stable and the parcel will tend to sink down. And for the saturated case, the saturated adiabatic lapse rate, it is less than the environmental lapse rate. So this will be same as the instability condition, because जो हमारा एयर पार्सल है वो कंपैरेटिवली स्लोली कूल डाउन होगा एज कंपेयर टू दी एम्बिएंट एनवायरनमेंट, तो वो जो पार्सल है वो हमेशा वार्मर रहेगा एज कंपेयर टू द एम्बिएंट एनवायरनमेंट, एंड दिस कंडीशन विल बी unstable. Clear? Okay. So this was your conditional stability. Now here is wet neutral. What is wet neutral? Here your dry adiabatic lapse rate is more than the environmental lapse rate, but it is the same as the saturated lapse rate. Basically, the environmental lapse rate here, ELR matches the saturated adiabatic lapse rate, SALR, which is equals to 6 degrees centigrade per kilometer. So the atmosphere in this case, since it is wet adiabatic lapse rate, and the in this case these two are equal, so the atmosphere will be neutral. So that is why it is termed as wet neutral. Similarly, one other case is dry neutral. So here the ELR now matches with the DALR, the dry adiabatic lapse rate, that is equals to ELR, which is equals to 9.8 degrees centigrade per kilometer. Since the atmosphere here is dry and the ELR and ALR are equal, so the condition will be neutral. So it is termed as dry neutral. Next one, extreme stability, inversion. So here, what in the case of inversion, the ELR is negative. So what does this mean? This means as that as we move upwards, the temperature of air tends to as we move upwards, the temperature of air tends to increase. Inversion condition, what is inversion? इन्वर्जन में क्या होगा, जब भी हम ऑल्टीट्यूड इंक्रीज करेंगे ना, तो टेम्परेचर इंक्रीजेज विद ऑल्टीट्यूड. Clear? So extreme stability condition, here ELR is negative. This indicates that the layering of the lower atmosphere is such that the warmer air lies on top of the cooler air. So basically inversion, uh, this phenomena is observed in winter season when the temperature on the surface of the earth is lesser. So what happens in these cases is that the temperature at the lower layer is cooler, uh, and as we move upwards it rises. So this phenomena is known as the temperature inversion. So and both the parcel lines are on the cool side of the ELR. So this condition is of the absolute stability, and in this situation no air parcel may rise, and this often has negative effects upon pollution dispersal. So this condition is very dangerous. So this is the reason why the level of pollution increases during the winters, because there will be no dispersion of the pollution, no or very negligible amount of dispersion that is happening in the atmosphere, and this will tend to the accumulation of the pollution or the pollutants in the atmosphere, and thus the air quality like worsens in the that is why the air quality worsens in the winter season. So what was our question? Guess this one. So I want answer from you guys. In this condition where ELR is here, DALR is more than ALR, which is more than SALR. So, what is this stability condition?
Absolute stable.
Are you sure? I think this was the same condition na, that was given in the question. DALR is more than ELR and which is more than SALR. Same now. So this will be the condition of conditional stability. Where this is stable and this is unstable. Clear?
Yes, ma'am.
So, okay, with this, the questions have been solved. So, I think now we can discuss your doubts for this class. If anyone is having any doubt, please feel free to raise your doubts.
Ma'am, once again explain the.
Hey, hi, please continue.
Uh, please, can you please repeat?
It's Kuldeep here.
Yes.
So, why we cannot control the pollutants or the suspended particles in the air using the negative ions?
Using?
The negative ions.
Okay, so basically you are asking about the ionization principle.
Yes, it is. Yeah.
Okay. So see what happens is ना कि अगर हम ionization करते भी हैं, so what
Mm-hmm.
happens ना कि what these ions tend to do, ये other particulates को attract करते हैं and they try to settle down. This
Yes.
is the whole purpose of this ionization ना. But due to certain activities ना, what happens is कि सारे फर्स्ट ऑफ ऑल सारे आयंस को सारे पार्टिकल्स को हम अट्रैक्ट कर नहीं सकते ड्यू टू दिस आयनाइजेशन प्रोसेस एंड अदर थिंग इज दैट कि वो पार्टिकल्स टेंड टू लाइक रीसस्पेंड इन द एटमॉस्फेयर ड्यू टू सम ऑफ द एक्टिविटीज अगर हम एक रूम में फॉर एग्जांपल इफ यू कंसीडर एन इंडोर एनवायरनमेंट तो अगर हम एक इंडोर एनवायरनमेंट में कर रहे हैं ये चीज तो आफ्टर सम टाइम क्या होगा इफ यू टेंड टू मूव इन द एनवायरनमेंट ना दैट विल आल्सो लीड टू द रीसस्पेंशन ऑफ द पार्टिकल्स.
Yes.
So that is why we cannot completely remove those particles.
But it is possible to remove some of the particles.
Yeah,
Means at
exactly.
least
So
30%.
basically, if we talk about the finer particles, they can be removed. For
Mm-hmm.
example, for PM like for PM 2.5 or PM 1 or lesser than that also. तो
Mm-hmm.
ionization से वो हो सकता है but for the bigger particles because you can like target one size or one type of particle at one time na. And in the
Right.
environment we have the particles in different size ranges
Okay. So these
and
particles
it
are
was
very
also
dangerous. Like
yeah
below the 10. Like
yes
the PM below PM10s are very dangerous. So we can bring out the coagulation in the suspended particles in the atmosphere, and we can increase the size of these particles, right? So let's suppose
right
we have the PM 2.5.
yes
As if we understand we can coagulate at least four particles together, and we can increase the size of these suspended particles. So the intensity, or what I can say, the risk of uh, these smaller particles can be reduced using this ionization technique, right? Or not?
Right. Yeah. See, this process of ionization, it is useful at a certain level, but it has also been observed that has some other risks associated as well. Just
Mm-hmm.
let me clear this. Huh? Um, just a second. Huh? बेसिकली व्हाट हैपेंस ना, आयोनाइजेशन प्रोसेस में क्या होता है, जो भी हम आयोनाइजर्स यूज कर रहे हैं ना, तो वो एक बार को पार्टिकल्स को दे टेंड टू इंक्रीज देयर साइज और उनको सेटल डाउन कराने में हेल्प कर रहा है, बट दोज आयोनाइजर्स व्हिच आर यूजिंग ना, दे यूज दे टेंड टू प्रोड्यूस टू मच ओजोन, एंड दैट इज इन वन वे हार्मफुल फॉर द ह्यूमन बीइंग्स. So that is why जैसे हम closed environment की बात करते हैं, this ionization process is useful in like open atmosphere. हम कुछ also there is some device also that has been patented that is called 0 pm 2.5 something like that. तो वो क्या करते हैं, वो एक जो भी हमारे कार से पार्टिकुलेट्स, जो भी कार व्हीकल एग्जॉस्ट से जो भी एमिशंस हो रहे हैं, वो उस एयर को आयनाइज करते हैं. तो व्हेन यू आयोनाइज दोज पार्टिकल्स ना, वो बाकी जो पार्टिकल्स एयर में प्रेजेंट है वो उसको अट्रैक्ट करते हैं, दे फॉर्म बिगर फ्लॉक्स एंड दे टेंड टू सेटल डाउन. बट व्हेन वी यूज दीज आयोनाइजर्स और द एयर प्यूरिफायर्स इन द इंडोर एनवायरनमेंट, so these tend to produce too much ozone, and that is
Yes.
harmful for the people's health. So that is
Yeah.
why these their basically their use is not recommended in the closed indoor environments.
But if we reduce the amount of the ozone, means
Yeah.
we are using any kind of a corona discharge or whatever it may be, and
Okay.
we anyhow we reduce the amount of
See,
ozone. That
yeah, this is a possibility. If we, if in any way we can reduce that ozone, na, then
Mhm.
this process is fine. This ionization process,
Okay,
because
okay,
the major parameter that is affecting here is ozone.
right. Yeah, got it. Thank you, ma'am. Thank you.
Thank you. Okay, anyone else?
Excuse me, ma'am.
Yes.
Just explain the practical problem we are facing at NCR location in the winter season, especially. How we can
Okay.
control the pollution. Just in an exaggerated way that we can understand the things in a little bit.
Okay, in NCR region. So, okay, I can discuss this topic in very much detail because currently I'm focusing towards the air quality in. I'm researching about the air quality in this NCR region only. So, see, basically, first of all, what we need to focus is now कि हम कौन सी air को target कर रहे हैं, whether it is ambient or the indoor air. Both have their own challenges. For example, in the winter season, inversion happens. Everyone knows that. So ambient air में already इतना pollution है, and the major factor that is responsible is the industries and the vehicles. इनकी वजह से जो भी emissions हो रहे हैं, they tend to like accumulate on the surface or on the lower levels in the atmosphere, and which tends to increase the pollution level. So एनसीआर रीजन में सबसे बड़ा पैरामीटर जो इफेक्ट कर रहा है ना इन द एनसीआर रीजन, वो है हमारा व्हीकल्स प्लस इंडस्ट्रीज। इनसे जो भी पार्टिकुलेट्स आ रहे हैं ना, दे आर अफेक्टिंग द एनवायरमेंट। और ये तो हो गई एम्बिएंट एयर की बात, बट द मेजर प्रॉब्लम हियर इज ना कि हम एम्बिएंट एयर से के बारे में बात कर रहे हैं, बट द मेजर फैक्टर जो हमें अफेक्ट कर रहा है दैट इज द इंडोर एयर पोल्यूशन, because we tend to spend approximately 80 to 90% of our time in the closed indoor microenvironments, whether it is your office, your school, college, or your home, or the vehicle that you are traveling in, basically your metros and other things. We are exposed to a lot of pollution in those indoor environments, and every type of indoor environment has its own set of parameters, or its own set of pollutants. And for the closed indoor environments, the main target pollutants, closed indoor environments, the major target pollutants are particulate matter, that is PM 2.5, and second one is CO2. These two are the major pollutants that are to be considered, because this CO2, that is basically what it does now. It is how can we say, ये indicator है, that this is the indicator for other pollution, other pollutants as well. It is basically, it is surrogate for the other pollutants. And this PM 2.5, this is the most dangerous, or the like जिसके बारे में इस समय हमें सबसे ज्यादा कंसर्न होना चाहिए इन द इंडोर एनवायरमेंट्स, इट इज दिस PM 2.5 and this CO2. So for example, if you consider a closed environment, and आप for example in your homes, अगर आप किचन को ले रहे हैं तो so when we are cooking ना, तो during that time this PM 2.5 level, this tends to increase to very higher values. For example, in some studies where I have found out ki in my own home also, I've placed a monitor, and I tried to monitor the indoor air quality during 24 hours of the day. So by the time when there was cooking happening in the kitchen, the PM 2.5 levels, these rise drastically. These tend to like increase to about like 900 to 1000, and at some time it was more than that also, ppm. And this is very high, like it is like hazardous. And similarly for CO2, तो इसका एग्जांपल, सबसे बेस्ट एग्जांपल है आपके व्हीकल्स। आप कभी भी कार में जा रहे हो एंड यू आर यूजिंग एयर कंडीशनर्स इन योर कार, आपकी सारी विंडोज क्लोज है एंड एवरीथिंग इज क्लोज, तो उसमें क्या होता है कि ये CO2 लेवल स्टार्ट्स आफ्टर लाइक 4-5 मिनट्स, क्या होगा, CO2 एक्यूमुलेशन स्टार्ट होता है। एंड आई हैव विटनेस्ड इट विद माय like on my own, कि ये CO2 levels are like more than 2500 to 3000 ppm, which is very much higher inside cars, closed cars. और ये एक वन ऑफ द मेजर रीजन है कि अगर हम एक ये यमुना एक्सप्रेस वे पे देखते हैं फॉर एग्जांपल, तो वहां पर जो एक्सीडेंट्स हैपन होते हैं ना कि सडनली आउट ऑफ कंट्रोल हो रही है कार, या कुछ हो रहा है, या यू स्टार्ट फीलिंग बेसिकली, यू व्हाट हैपेंस ना कि अभी भी कभी भी आप एक क्लोज माइक्रो एनवायरनमेंट में जाते हो जहां पर एयर कंडीशनर्स हैं, सारी चीजें हैं, तो आफ्टर सम टाइम ना व्हाट हैपेंस इज you start feeling like sleepy or feeling tired, you don't feel that much fresh, or your concentration level starts to decrease. So this is due to the buildup of this CO2 levels inside those environments.
Ma'am, this is happen in the winter season or throughout the year, especially?
See, basically pollution is there throughout the year, but winter season में especially Delhi में क्या होता है ना कि वहां पर विजिबिलिटी इतनी ज्यादा इफेक्ट होती है कि यू स्टार्ट लाइक हम जब तक किसी चीज को विजुअलाइज नहीं करते हम उसको फील नहीं कर पाते हैं। तो विंटर्स में पोल्यूशन लोड जो होता है थोड़ा सा इंक्रीज हो जाता है ड्यू टू दिस इन्वर्जन थिंग। तो हम लाइक कंपैरेटिवली दीज आर
Hello,
हायर
ma'am.
विंटर में, बट इट इज
Hello,
देयर थ्रू
ma'am.
आउट द ईयर। यस
Hello, ma'am.
यस यस।
I'm from another language, ma'am. Speak in English, ma'am.
Okay, no issue, no issue. Okay, I'll try to speak in English. Okay, fine. Any other doubts? Any other doubt that you guys have? Any topic that you want to discuss, or if you are having doubts in any topic, and we can take that as well. Are there any topic that you want to discuss in this class?
Hello. Hello.
Yes.
Which instruments are used in indoor air quality measurement? So,
You're not audible. Like you're not clearly audible. Can you please repeat your question?
instruments are used in indoor air quality measurements, air pollution.
Okay. So, there are some low-cost sensors. They can be used for day-to-day indoor air quality measurements, but for the laboratory equipments or the research grade equipments. So, for the measurement of particulate matters, there's this
Okay.
instrument that is called a Grimm spectrometer that gives us the concentration of the particulates in the atmosphere.
Mm.
And I think for the measurement of CO2, we also have a research grade instrument.
But some low cost sensors are also there for the like indoor air quality monitoring.
Specific name of the sensor, ma'am.
There are multiple sensors. Like for like every company has its own. For example, the low cost sensor that I'm using is from a company called Kytera. So this
Okay.
has a live air quality monitoring system, and it gives
Mm.
us the values of PM 2.5, CO2, and your temperature, humidity, and the air
Mm.
quality index. These are values that it gives.
Okay. Thank you, ma'am.
Anyone else?
Excuse you.
Yes.
Actually, ma'am, how it is related to ventilation system, indoor and outdoor ventilation? Uh, this air pollution and control subject.
Okay. See, as far as indoor air pollution is considered, it is very much related to the type of ventilation that we are using, or the or the amount of ventilation that we are having in closed indoor environment.
Yes.
Because what happens is, eventually, for example, if we consider a environment that is artificially ventilated, like, for example, if we are using centralized air conditioning systems or some other systems, so
Right.
the problem is that the buildup of CO2, यहाँ पर क्या होता है ना सब basically what happens here is ना कि the problem of the buildup of CO2, that is a that is of prime concern for us. And this CO2 and ventilation, they are very much closely interrelated. For example, if we consider our homes also, so while, for example, while doing some indoor activity, like while cooking, or if we burn an incense stick in the in the room, so if we like close all the doors and windows, what will happen is na कि जो भी whatever the particulates that are being emitted due to these activities, they will
Mm.
remain in that closed environment only. They won't
Mm.
like move out of the space, or they won't disperse in the environment, and this will increase the level of pollution. So in one way, ventilation helps us to decrease the pollution in the like closed environments, because like if we open the doors and the windows, and if the pollution load in the in that environment is higher, what will happen is the pollution will naturally decrease due to the dispersion of pollutants from that indoor into the ambient air. But it is
Okay.
like it has the other way round also. For example, if we consider a space where the level of pollution is very much higher in the ambient air, so and if we try to if we try to allow the ambient air to move in one way or the other to penetrate into that indoor environment now, what will happen is the pollution load will ultimately rise, and the level of air quality will degrade.
Right. So can you suggest some books related to ventilation system in connection with this air pollution and control? Because
Okay.
I'm in
See,
HVAC field.
right now I don't like I instantly don't remember any name, but I will definitely suggest in the next class. I will take you out, and I will
Yeah.
definitely suggest you some very good books about the ventilation systems.
Sure. Thank you, ma'am. Thank you.
Okay. So anyone else, if they are having any doubts, they can ask any kind of doubt related to air quality or your day-to-day concerns related to air quality. Is there anyone who is
Excuse me, ma'am.
I think some mic is unmuted. Please mute it.
Are you hearing me?
I'm hearing.
Ma'am, I have some question, not related with the doubt, but can it be the interaction session be changed on other than the Tuesday? Actually, the same class being two times I have just missed the water and water management NPTEL exam question
See,
session.
see, you guys are, yeah. See, you guys are having 3 tutorial sessions per week for the same assignments. One, basically, you have 3 TAs for this course, and each one is covering the same assignments like per week. So my lecture is on Tuesday. So from my end, I can't change this lecture, but you have an option to change your like to attend any session. I think one is on Sunday and one is on Monday as well. I don't exactly remember the timings, but you are free to enroll in any session, or you are free to enter any session. Because from my end, I have been allotted this 6 to 8 p.m. every Tuesday. So I can't. Ranjit, please turn off your mic. Okay. So I can't change the timings from my end, but you guys are free to like attend any session because you are having 3 sessions per week for the same course.
Okay, ma'am. Thank you.
Anyone else?
Excuse me, ma'am.
Yes.
Yes, ma'am. Actually, I want to ask you one question regarding this spice manufacturing factory. How we can control air pollution inside the spice making factory? Any idea? Or can you suggest some tutorial books वगैरह?
Okay, so basically, before suggesting any remedial measures, it is very necessary to understand the environment inside that. In basically, it is very much important to understand the potential pollutants that will be present inside that micro environment that we are considering.
Right.
So, for example, as you're saying, the spice manufacturing factory. So, see, first of all, we need to visit that place because every place has its own challenges.
Hmm.
What kind of activities are going on there? What are the processes that are being involved, and what are the target pollutants? Because see, every space has its own challenge. Agar space, if it's too small, then maybe the process the number of workers are too high, so there's a chance that the level of CO2s would be very much higher. And also if like in the process of grinding or the crushing of those spices, so also there will be like abrasion happening, and due to that the particulates will also be getting emitted. And
Hmm.
also, like, what kind of environment is present there? For example, what kind of ventilation facilities they are having? Is it a closed environment, or they are using natural ventilation? All these factors matter a lot in suggesting any kind of remedial measure in any environment.
Right, right.
So
So
you
we have
have
to
to.
take some input. Uh,
Exactly. At least we should know the activities that are being done there, or the or the basic geographical idea about that place.
okay.
What equipments are being used? Are there any air purifiers that they are using already, or the kind of ventilation that is being given to the kind of ventilation that they are using? Is it natural or artificial? If it is artificial, then what kind of artificial ventilation that they are using? All these factors, basically, see, uh, once you enter any micro environment or any closed indoor environment, just try to just close your eyes and just try to imagine the potential sources. For example, what are the inlets and outlets that are there in that environment? How many doors
Right.
and windows? What are the direction, wind direction?
Hmm. Right.
अगर वहां पर if the wind is coming तो किधर से आएगी? How will it will flow? Are there any stagnant pockets जहां पर ऐसा हो सकता है कि अगर कोई stagnant pocket है and a pollution source is present in that area, तो it's a chance कि वहां पर बहुत high level of pollution होगा.
Or either how
Mhm.
this Indian industry norms allows that exhaust air to be exhausted outside of the atmosphere. So what are the criteria norms not to exhaust much, or you clean inside only? Maybe some chimney, right? We
Yes,
can provide. We have
basically
to.
there are some norms that have been set about towards the emission of those pollutants from the industries. You can find them in the National Ambient Air Quality Standards, and
Right.
it is assumed that every industry or every factory that is like that is processing its air before releasing it to the ambient environment.
Yes, yes, that's point I'm asking. So can you suggest that a standard is available free in any, or can you share that a standard NAV, NAQS, National Ambient Quality Standard, available in Google or in chat box? Can you share any book or any material?
See, I think it is available on the site of US EPA, United States
US?
US EPA.
Okay,
You just Google NAAQS, National Ambient Air Quality Standards, and
okay,
the first
okay,
link that is there now, that is by the US EPA,
okay,
United
okay,
States
okay.
Environmental Protection Agency, and
So we got, yeah,
you will get all the standards for all the pollutants, and the like for average time intervals is also given, the for the 8-hour interval or the per year the level of emissions,
okay.
those are given there.
So it is
And
given
also,
based on.
for the Indian scenario, you can use this like CPCB website now, the
Yes.
Central Pollution Control Board, cpcb.nic.in. It has all the standards for the Indian scenario, all the acts and rules, everything is there. You just open their portal once and you will get everything there.
Right, right. Thank you. Thank you, ma'am.
You can also get the like daily data for different at least for the NCR region they have installed their monitors, so the live air quality monitoring system is also there on their website. You can check that out.
So any city, I'm from Ahmedabad, so we can get those data a daily basis from Ahmedabad,
Yeah,
Gujarat.
I think they have it for the at least for NCR region. Let me check for the Gujarat or
Okay.
the
Okay, no issue. You can
yeah,
share later on
yeah,
next
yeah,
lecture.
definitely.
Thank you, ma'am.
Okay, welcome. Anyone else? Okay, so I've checked it. For every state, they have the live air quality monitoring system. For Andhra also, they have certain. You have to specify the state, then the city that you are like that you want, the air quality index, and also the station. They have different stations for every city, and you get the pollution level for like for different pollutants: PM 2.5, PM 10, NO2, ammonia, SO2, carbon monoxide, and ozone. Everything's there on their website. You can also download the data from their website also.
Okay, okay. On CPCB website, right?
Yeah, CPCB, Center Pollution Control Board.
Okay, okay. Got it. Thank you.
Okay. Okay, so is there anyone who's having any other doubt? Because I'm going to wrap this session. It's already 7:47. So if you guys are having any doubt, then we can take that, or else we can end the session now.
Anshu, are you still there in the class? Okay, so there was this question that has been asked by one of the student. Calculate the sub-index for the given conditions. Let me take this question. Okay. So the question is calculate the sub-index for the given conditions. Sub-index II. We have to calculate this, and the conditions are given as PM10 concentration is PM10 is 90 ppm. BHI is 100. BLO is 50. IHI is 100. ILO is 50 and CP is 85 micrograms per meter cube. So the formula for this subindex IP subindex formula IHI minus ILO divided by PHI minus BLO multiplied by CP minus BLO and this whole plus ILO. So what's this BHI? BHI is breakpoint concentration higher or equal to given concentration. So here BHI is 100, which is higher to given concentration. So we'll take BHI as 100 minus BLO. BLO is breakpoint concentration lower or equal to given concentration. It is lower to given concentration. Given concentration is 90. So BLO will be 50. What's this IHI? Given IHI is 100. So IHI is the AQI value corresponding to BHI. IHI is given as 100 minus ILO is 50 and it will be multiplied by CP is 85 minus BLO is 50 and this whole plus 50. The value that we get by solving this now, that will be your subindex. I hope this doubt is clear for Anshu. Okay, so I think we're done for the day. As you guys are not having any other doubts, let me end this session. Okay, see you guys next week, same time, 6 to 8 p.m.